right, so this is a spiral review, and it is on right triangle, trig, and radicals. All of the things that are in these notes you have done before. We just need to brush up on them before we move into our next chapter. All right, so the first set of examples says use the Pythagorean theorem to find the missing sides of each triangle. So remember, the Pythagorean theorem is side squared plus side squared equals hypotenuse squared. So if you look at example 1a, our hypotenuse is x. So we can say the sum of our sides squared, 5 squared plus 12 squared, is equal to x squared. And now we can use Pythagorean theorem to solve this. So we have 25 plus 144 is equal to x squared. 169 is equal to x squared. Square root to solve. Now remember, whenever you square root to solve, you have to account for the positive and negative solution. So we get x equals plus or minus 13. But we can't use the negative answer because that is the length of this size, right? This side, not size, the length of this side. And this side can't be negative 13 units long, so it's just positive 13. So from now on, when doing the Pythagorean theorem, know that you should do the plus minus for the algebra, but the positive answer is going to be the only answer that works. Now, before we move on to the next one right here, notice that the answers for this side are 5 for the leg, 12 for the leg, and 13 for the hypotenuse. This is called a Pythagorean triple. It is because that if you have legs that are 5 and 12, the hypotenuse will always be 13. If the hypotenuse is 13 and one of the legs is 12, the other side will always be 5. So there's a few Pythagorean triples that you could memorize to make your life a little bit easier. So the most common one that we see is 3, 4, 5. So a 3, 4, 5 Pythagorean triple is if the legs are 3 and 4, the hypotenuse is 5. Also, please keep in mind, if you know the hypotenuse is 5 and one of the legs is 4, then you know that the other leg is 3. All right, so that's the explanation that I'm going to use for all of them, and I'm not going to keep saying that over and over again. So 3, 4, 5, 5, 12, 13, which is the one we just did. What else do we see a lot? 7, 24, 25, 8, 15, 17, and 9, 40, 41. So these are the ones that, and there's many, many more of these. But these are the ones that I have memorized in my head. 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, and 9, 40, 41. So if I ever see those combinations, then I don't even have to do Pythagorean theorem. Good news is if you forget them, you can still use Pythagorean theorem. Also, please realize that if you double, triple, quadruple any of those are also triples. So if I doubled every number here and did 6, 8, 10, that's another Pythagorean triple. Okay, if I tripled them, 9, 12, 15, that's another Pythagorean triple. Okay? All right, if you look, this is not one of our triples, so we definitely have to do Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So we're going to do 5 squared plus x squared, or x squared plus 5 squared, it doesn't matter, equals 7 squared. So we have x squared plus 25 is equal to 49. Subtract 25 from both sides. X squared is equal to 24. And now we want to square it to solve. Remember, when you're square rooting to solve, we do plus or minus in our algebra. And then we want to write our answer in simplest radical form. We can forget the plus or minus, but I'm going to leave it here for now and just not write it in my answer. So we know the perfect square of root 4 goes in there root 6 times. So this is 2 root 6. So our side is x equals 2 root 6, not plus or minus 2 root 6. All right, if you're like, can we just not do the plus or minus? We're going to be working with triangles that are in the second quadrant, in the fourth quadrant, in the third quadrant, in the first quadrant, and we're talking about direction. We all have to include the negative, so it's a good habit to just keep the plus or minus there and then think about whether or not you need it. All right, next, if you look, we have the next 3 problems. For each problem, find the answer to the nearest thousand. So we're going to do 2 decimal places. If you look at these 3 right here, the first one has a missing angle and you're given 2 sides. The second one has a missing side and you're given an angle and a side. And the third one, same thing. So whenever you have a side and an angle, or two sides and you're missing an angle, or an angle and a side and you're looking for a side, you can use SOHCAHTOA as long as it's a right triangle. So to remind you of what SOHCAHTOA stands for, sine is the ratio of opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you look to see what you have right here, so this is my angle. The 30 does not touch it at all, therefore it's opposite. The 18 touches that angle, but it's not the hypotenuse, so that's adjacent. O and A tells me to use tangent. So we have tangent of x degrees is equal to, and then remember it's O over A. So opposite, which is 30, over adjacent, which is 18. All right, now I need to get rid of tangent. To undo tangent, I need this to go away, right? We use its inverse, which is tangent inverse. So what we do to one side, we have to do the other. So we have x equals tangent inverse of 30 over 18. And now we can get our answer using our calculators. Now, 99% of the time, I gotta find my Chrome, we have you do 3 decimal places in pre-calc, but this one specifically says hundredth, so I'm going to follow the directions. Oops, and I'm gonna take graph, I'm gonna take clear, okay. Pull back up my notes. Sorry, I should have had this ready, but I didn't think. All right, so first off, if you look, this is in degrees. I have 24 degrees, 58 degrees, x degrees in my triangle, so I have to make sure I'm in degree mode. So I'm gonna hit the mode button. I'm gonna go down 3, and I see it's in radian mode, so I wanna switch it to degree mode. And now I can do tangent inverse, so that's second tangent, and then 30 divided by 18, round to the nearest thousand, 2 decimal places. So, no, that's not, it's 3 decimal places. I just said 2 decimal places like 5 times. 10th, 100th, 1000th is 3 decimal places. Oh, goodness. All right, so that's 59.036 degrees. All right, usually in pre-calc, we round to 3 decimal places, and it says thousandth, so that's 3 decimal places. I was thinking hundredth in my head for some reason. All right, here's the next one. Here's my angle. This is the hypotenuse. This side touches it, so that's adjacent. A and H tells me to use cosine. So if you look, A and H is cosine. So I'm gonna write down cosine of 24 degrees is equal to the adjacent side, which is 31, over the hypotenuse, which is x. Now I'm solving for a missing side. Remember, you're solving for a variable and a fraction here. So the easiest way to solve this is to make this a fraction too, and then cross multiply. So I have x times the cosine of 24 is equal to 31. And now I need to get x by itself. Remember, this is multiplication right here. So I'm going to divide both sides by cosine of 24. Forgot about my divided by there. So now I have x equals, and now I'm going to put this in my calculator. 31 divided by cosine of 24. Hit enter, and once again, 3 decimal places, 33.934. And this is a side length, so it's not in degrees, it's just in units, which they didn't give me like centimeters or meters or anything like that. Okay, last but not least, here's my angle. This is opposite and hypotenuse, so I'm using the trig function sine. So sine of 58 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 18. Once again, your variables and your fractions, so I'm going to make the left-hand side a fraction 2 by putting it over 1, and I'll cross multiply. 1 times x is x equals 18 times the sine of 58 degrees. Now I can put that in my calculator because x is already by itself. 18 sine 58, close the parentheses, and I get 15.265. And once again, that's a side length, so I'm not putting degrees on it. Okay, next one is a word problem, and it says a plane is flying at an altitude of 12,000 meters. From the pilot, the angle of depression to the airport is 32 degrees. How far is the airport from a point directly beneath the plane? So first off, I want to draw a picture that represents this. So we have an altitude, right? Altitude is another word for height of 12,000. Put a little comma there so we can make sure it's 12,000 and it's meters. All right, from the pilot to the angle of depression. So angle depressions occur in right triangles. I do not have a right triangle drawn here yet, so what I want to do is I want to make this into a right triangle. Okay, so there's my right triangle. All right, so when I teach this in integrated, or when I taught this in integrated, how I would teach it to my students is I would say, okay, we're going to call this A for altitude, B because this is the base, usually the ground, C because we call hypotenuse C. An angle of depression is never drawn in your picture, so what you have to do is you have to make an auxiliary line here, and then the angle coming down from that horizontal line, that's your angle of depression. This angle coming up from this horizontal line is the angle of elevation. And if you call this an angle of depression or elevation, you're going to get an F on the problem. That's what I tell my students. So it says the angle of depression is 32 degrees. So I'm going to erase that D right there and put 32 degrees. And then I can erase this F and this A and this B and this E and this C. Question is how far is the airport tower from a point directly beneath the plane? All right, so here's the plane. We never even actually, let me draw my wonderful, there's the plane, okay? And then here's the airport tower right here, right? So it says how far is the tower from a point directly to the plane, which is from here to here. So I'm looking for this, which is X. All right, now we can use SOHCAHTOA to find this. If you notice, we have no angle inside the triangle, but because we have parallel lines, we know alternate interior angles are congruent, and this is 32 degrees. So now I can use this angle in the triangle. I have this is opposite, this is adjacent, so I'm using tangent. So we're going to say tangent of 32 degrees is equal to TOA, SOHCAHTOA, O over A. Opposite, which is 12,000, over adjacent, which is what I'm looking for. Solving for X in the fraction. So I'm going to put my trig function over 1 and cross multiply. I have X times the tangent of 32 is equal to 12,000. And then to get X by itself, I'm going to divide both sides by tangent of 32. Put that in my calculator. 12, 1, 2, 3, divided by tan 32. Hit enter, and we have X equals 19,204.014. And then we need a unit on this. This is a distance, and it said our distance was in meters. So there is our answer. All right, last but not least, this is just practicing on simplifying each radical, including rationalizing a denominator. Okay, so we need to simplify the square root of 32. 32 is not a perfect square, so we need to see if there are any perfect squares that go into it. If there's a perfect square that goes into it, we want to write it right here, and we want the biggest perfect square that goes into it. So I'm going to make a list of perfect squares. 1 squared is 1, but I never write that down because 1 goes into everything. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and I've already passed 32. So I don't need to even consider 36. So now I want to work this way. I want to see the biggest numbers. That's why I want to work that way. I can just be like 4 goes in there, but that's not the biggest number. 25 doesn't go in there, but 16 does. So this number right here is 16. 16 goes into 32 twice. And then whatever you write down here is always simplifiable. The square root of 16 is 4. So this is 4 root 2. Okay, next we have a fraction. We're square rooting a fraction. So remember, if you want to square root a fraction, you square root the numerator and you square root the denominator. If you look at the denominator, we know the square root of 9. So this is root 5 over 3. Okay, moving on to the next one right here. This is 1 divided by root 3. You might be saying to yourself, what's wrong with this? Like, it looks fine to me, but it doesn't. It's not rationalized. Rationalized means that you can't have a radical in your denominator. So what we want to do to make sure that there's no radical in the denominator, we just clean it up. We're going to multiply by 1. So we're going to multiply by a number over itself, and at the same time, it's going to make the denominator no longer a radical. The radical that we're going to pick is the radical that we were given. So we're going to multiply by root 3 over root 3. Notice this is just, we're multiplying by 1, so we're not changing the value of the answer. So now you multiply straight across. 1 times root 3 is root 3. And then root 3 times root 3 is root 9, which is just 3. So remember, any radical times itself is the number underneath the radical, the radicand. All right, this one right here, same idea. You can't have a radical in the denominator, so we're going to multiply it by root 2 over root 2. 10 times root 2 is 10 root 2. Root 2 times root 2 is 2. Now, the only difference between this and the last one, this fraction is simplifiable because we can simplify 10 over 2. You can't touch the radical. You can't touch the root 2. We can simplify 10 over 2. 10 goes into itself 5 times. Sorry. 2 goes into 10 5 times. 2 goes into 2 once. So I have 5 root 2. We're not going to put it over 1. We don't ever leave an answer over 1. All right, that's it for our review.